All right, looking at some integrals on 785. A is the integral of negative 2 over x dx. I think the best way to choose to rewrite that would be negative 2x to the negative 1 dx. Now, when we integrate this and add 1 to the power, we would actually get x to the 0, which is bad because we should have an x in it. So we need to remember that the derivative of 1 over x is the derivative of the natural log of x is 1 over x. So the antiderivative of 1 over x is natural log of x. So it should just be negative 2 times the natural log of x plus c. Then let's look at b. The integral of 2 over the square root of 1 minus x squared plus 4x. Okay. So because of what we're doing in class, you would be thinking u substitution, but we really need to realize that this is, when we have addition, there's like two separate problems going on. This side of it here is nice and easy. That should just be 4x squared over 2 plus c. When we look at the first one, you may be thinking u substitution, but if u is going to be 1 minus x squared, then du is going to be something with a 2x in it, which I don't actually have a 2x here. So because there's no chain rule to undo here, that's not going to work. A u substitution is not going to work. This is one of those problems we talked about on that day where we just have to know that this is our derivative of sine inverse. So this is just going to be 2 times the sine inverse of, in this case, x plus. So that would be one where, because of the u substitution we've been doing, I could see us getting confused on.
One in the back of the book.
So a memorization, recognizing that that looked like one of our inverse trig derivatives. And then the last one, the integral from 0 to pi of pi x. That's going to have an undo chain rule. What derivative gave me pi to the x? It had to have been pi to the x. So 1 over the natural log of pi times pi to the x. The derivative of that would be pi to the x because it would be multiplying by the natural log of pi from 0 to pi. If we put the pi in, we get pi to the pi over the natural log of pi minus, if I put the 0 in, 1 over the natural log of pi. Looks crazy, really not that bad.